Morning everyone, welcome to electric vehicle YouTube channel. So in our YouTube channel you have been seeing a number of videos on electric vehicle, so which has a set of videos which describe about different parameters of electric vehicle and how the electric vehicle works and what are different motors used. So those who are new to the channel, you can go to the channel and you can watch all the set of 10 videos which are available on electric vehicle. So the intention of this channel is to promote green energy as well as to promote electric vehicle and to create an awareness in the customers. So the customer can take a decision which electric vehicle he has to purchase and what are the specifications he has to see while buying a new electric vehicle. As a part of this, after the purchase of this new electric vehicle, they need to install a solar plant of their own. Why? Because electric vehicle comes under the category of green energy. So we want to make the environment, we have to use the power which is an green power rather than charging the electric vehicle with thermal plants. So as a part of this resolution, you may have an electric vehicle, you can charge your electric vehicle at outside, which is also an green energy electricity. Or if you are planning to establish an EV charging station, so you need to know about the design of an solar panel working. So coming to the concept, so today we are going to discuss how a solar panel is going to work. So coming to the concept, so you can have a solar panel like this. So actually from the sand we are going to purify it and we are going to get the silicon, and from the silicon we are going to make it like a wafer and we are going to construct an solar PV panel like this. Each solar PV panel consists of an solar cell. Now coming to the physics behind this solar cell working. So let's try to understand what is the physics behind how a solar cell works. So coming to the concept, so you have a top layer. So the working of a solar panel is similar to that of an working of an PN junction diode. So if you try to understand the working of this PN junction diode, then you can understand how this solar panel works. So actually coming to the semiconductor category, so you have intrinsic semiconductor as n-type here, and we have p-type intrinsic semiconductor, and now we are going to add the impurities of phosphorus in n-type semiconductor, which will convert this total material intrinsic plus doping, which is called extrinsic semiconductors. And this p-type material is doped with boron, which will try to create an extrinsic semiconductor, where p-type semiconductor is an intrinsic semiconductor and boron is nothing but the impurity we are going to add. Now we are going to have an p-type extrinsic semiconductor. This is an n-type extrinsic semiconductor, this is a p-type extrinsic semiconductor. Now in this class let's try to understand how this configuration is going to occur. So coming to the concept, so at the top you are going to have an n-type semiconductor. At the bottom you are going to have a p-type semiconductor. Now let's try to draw its crystalline structure. Already I told, so the intrinsic semiconductor is silicon. So coming to the atomic structure, in its valence band it has one electron, 4 electrons in its valence band, 1, 2, 3, 4. Similarly also here you have in p-type also you have silicon, and in the valence band you are going to have 4 electrons. Now when you are going to add the impurities in n-type semiconductor, the impurities like phosphorus or arsenic or antimony, so the phosphorus is going to have 5 electron in its valence band. So electron 1, electron 2, electron 3, electron 4, and the extra electron I am drawing here. Now there exists a covalent bond between the silicon as well as phosphorus. Like this is one structure. Okay, and similarly there exists a covalent bond between this silica and the next silica. So this silicon atom and next silicon atom. So this silicon atom and next silicon atom, and similarly you'll be also having a an covalent bond established between this electron, and this is called a covalent bond. Similarly, you are going to have a covalent bond between this electron and one more silica which is available here, and one more silica which is available here. Similarly, you are going to have covalent bond. So this is actually the internal diagram or crystalline diagram of an n-type semiconductor. So you can see here all the electrons in the valence band are 4. After bonding they will be having 8 electrons